All right, how's everybody today? I'm doing well, thanks, sir. We are going to continue with special right triangles today. Yesterday we spent a lot of our time talking about the 30, 60, 90s. Today we'll go ahead and talk about the 45, 45, 90s, and there's just a little review right at the end. And tomorrow we'll go ahead and be able to start inverses of trig functions now that we feel a little more comfortable or have been refreshed on the special right triangles. Okay, don't forget a couple things. On Friday you have your exam. It's going to be over graphing the trig functions. You'll have one where you have to graph. There'll be some multiple choice. I also did put some law of sine and cosine problems on there for review. Angel? Yes, yes, yes. Let me get that out real quick. Did anybody else need the answer key for yesterday's homework? Okay, thank you, sir. Pass that to Angel. All right. Okay, let's see. Then you got yourself a 3-day weekend. Really, after this week, you only have the 2 weeks left. I'm currently getting the reviews and the finals together because that last week, we have to have a final. It's going to count 10% of the grade. But I'll be getting you more information on that as I get it done. It's definitely going to be multiple choice, something that I can just quickly grade, put in the teams, and, we can all get out of here on, I think they're doing them in order this year. Thursday, the 21st, is going to be 1 through 4, and then Friday, the 22nd, will be 5 through 8. So
That's crazy how close it is to Christmas.
it's really close.
3 days before Christmas.
Yeah. But the good news is we get to spend a little bit of time, basically the first week into the new year, we get that off. I remember a couple years ago, we got off about a week before Christmas, which was good because it gave you time to get things finished, but then the day after New Year's, we had to go right back. So it was.
I liked it better when, we were all just chilling. We lived our best life.
Yeah.
And it was, you would get off like a week and a
Well,
half.
when was there a time when we didn't go to school?
Friday.
Yeah, I do miss the half-day Fridays, I'll tell you that. Yeah.
It felt like
I'll never forgive the school for that.
Yeah. Yep. All right. Let's see here. I think this is as far as we got yesterday. There are additional notes over there by Adolfo if you need them right there on the Chrome cart. Otherwise, let's go ahead and take a look. So we were talking about 30, 60, 90 triangles yesterday, and we'll review those in just a bit. But now let's go ahead and turn our attention to the only isosceles right triangles that we have. What does isosceles mean? There you go. Two sides are going to be congruent. There we go. So when you're dealing with the 45, 45, 90, the two legs, and this particular resource used the variable n, so that's perfectly fine. So the two legs are always going to be the exact same length. They're identical, so n and n. The hypotenuse is always the leg n times the square root of 2. It's always one of the legs times the square root of 2. So let's look at a couple of variations of these. And again, I'll do like I did yesterday. We'll go ahead and run through. Here we have a 45-45 triangle where a leg is 8. So that's n, and then the hypotenuse is n square root of 2. Okay. Well, you always want to go ahead and take the leg you have, the actual length, and set it equal to the expression. So right away, we can see that n equals what? N equals 8. Okay. So I know that this other leg has to be 8 as well. And what's the hypotenuse? 8 square root of 2. All you do is substitute in. Okay. Now, sometimes it might take a little bit of algebra if you are working backwards from, say, the hypotenuse, and we'll see one of those actually in just a second. But let's try number 2. However the triangle is oriented, if that's 45, then that's got to be 45. So I know this is n units long, hypotenuse n square root of 2. Okay. So what is n? Yeah, 14. We can see that the length and our expression are equal to each other. So that means x has to be 14. So y should be what? 14 square roots of 2. There you go. Then on number 3, we have ourselves a square. And it looks like, what do we call that that connects two opposite vertices? Starts with a D. Diagonal. There we go. We're trying to find the length of the diagonal. These little tick marks are telling me that we are dealing with a square. So 18, 18, 18. Hey. Now, the diagonal will bisect the angle that it's coming from. So this angle was 90. So that means we have 45, 45. And even if you're not given the angle measures, if the two sides are of equal length, you know we have to be dealing with a 45, 45, 90. Okay, so can anybody help me out? What is the length of x? 18 square root of 2. There we go. Because right here we have ourselves a 45, 45, 90 triangle. Okay. Well, let's go ahead and take a look at number 4. Now, this one's different because I'm given the hypotenuse, and I want to find the two lengths. You'll notice we don't have x and y. They're both x because they're going to be the same. So the two legs are always n units long. The other one is always n times the square root of 2. So this is one I was referring to. We're going to have to get a little bit of algebra. So the length that I have, 18, I'm going to set that equal to n square root of 2. All right. Well, how would I solve for n? Yeah. Go ahead and divide both sides by the square root of 2. All right. So n is equal to 18 over the square root of 2, but we can do something with that. What am I referring to? Rationalize it. There we go. That means I want to remove the radical from the denominator, so I'm going to multiply that radical by itself. But whenever I multiply the radical by, okay, I got to multiply the numerator by the same thing. All right. Okay, so Brandon says 18 square root of 2 over 2. There we go. 18 over 2 would then become 9 square roots of 2. So I know these two legs each have to be 9 square root of 2 units long. There we go. Just like that. Just like that. Now, number 5 is going to be the exact same. I'm given the hypotenuse, which is always n square root of 2. And I want to find the lengths of the two legs, which are n. Okay. You want to try this one on your own? Okay. It's just the same way we work number 5. Or number 4, excuse me. We're on number 5. So we'll set up our equation, solve, rationalize, simplify if we can. Okay, well, let me go ahead and catch up to you. You may not be quite done, and that's okay. So I'm going to set up my equation. I'm going to take the expression and set it equal to the length I have for the same side. See, they're both the hypotenuse. What next? Okay, divide by the square root of 2. Okay, so those are going to cancel. You could, yeah. If you realize that's going to happen, you could always do that, yeah. Okay. There we go. And then we'll rationalize. So this is going to give me 8 square root of 2 over 2. And then 8 halves is 4. There we go. So both of these legs should be 4 square roots of 2 units. Whatever we're talking about. Centimeters, inches, feet, whatever. How many people got that right? Good, 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 good. Okay, we're doing the same thing on number 6. We want another diagonal of a square. We know that it's going to bisect the angle that it's coming from, so we have a 45, 45. So I'm going to say 10 equals what? N square roots of 2. Because both represent the length of that hypotenuse. That square is going to be divided into 2 right triangles. So just like we've done, divide by the square root of 2. Okay. So n equals 10 divided by the square root of 2. And what do I do again? I keep forgetting. Rationalize. Okay, so I'm going to multiply square root of 2. Square root of 2. Oh, if you can give me the final answer, I'd be happy with that. There you go. 5 square root of 2. Is everybody okay how we got that? Does anybody want me to actually go ahead and show that middle step? No? There you go. So I know all the lengths for the sides of that square have to be 5 square root of 2. Perfect. Perfect, perfect, perfect. Okay. Well, let's see what else we got here. Sketch the figure that is described. Find the requested measure. Okay, so it says the perimeter of a square is 48 meters. All right. Huh. Meter? I don't even know her. Yeah, see? Yeah, it was a joke. Yeah, okay. I said meter. I don't even know her. Meter. Ah, there you go. You smile. Guess I'm getting old. I could have sworn I heard somebody. Okay, so I got a square. What does it mean perimeter? There you go. That means if I add all 4 sides, I'm going to get 48. So I'm going to say, okay, let's say S represents the length of one side. So 4 times one side's got to be 48. So what's the length of one side? Yeah. Okay, so I know the length of one side's got to be 12. And I'm just going to put a little tick mark there to let me know that they're all congruent. But I want to know the length of the diagonal. There you go. We have one of the legs. All you have to do is multiply it by the square root of 2 if you're looking for that hypotenuse. Oh, was it 12 or 6? 12. Okay. All right. Is everybody okay with how I worked that one? Oh, yeah, I'm sorry. I had those unplugged because somebody wanted to use my pencil sharpener. There you go. The perimeter of a square is 20 centimeters. Find the length of a diagonal. Well, we have the exact same scenario. Let me go ahead and draw a square here. Okay. All right. Well, again, the perimeter is the sum of all 4 sides. So if 4 times the side is equal to 20, we know that one side has to be what? 5. Okay, so one length is going to be 5 centimeters. And again, we want that diagonal right there. Okay. Well, this one, I mean, all we got to do is, for the hypotenuse, take a leg and do what? Oh, square root it? Or what'd you say, Brandon? There you go. Okay, now I know I heard somebody that time. Okay. I'm losing it. So that diagonal is 5 square root of 2, in this case, centimeters. Okay. And I think this is our last set right here, because then after that, there you go, we get into our assignment. So let's go ahead and review one we haven't seen today. Let's do a 30, 60, 90. So you want to do 13? Okay. Ooh. Everything okay? Oh, water bottle. All right, so let's take a look at 13. So we have a 30, 60, 90. Now remember, the relationship between the sides here was a little different. Whatever's across from 30 is always n. Whatever's across from 60 is always n times what? The square root of 3. Now the hypotenuse is always n times 2. So what's the equation I want to create to help me figure out n? Yeah, there you go. Because we know 2n and 20 both represent that same side, right? So if 2n is equal to 20, well then n equals 10. So right away I know the height. This guy right here has to be 10. That's a 10. Okay. And then what's the value of y? Okay, it would simply be 10 square root of 3. Remember, for a 30, 60, 90, you base everything off the shorter leg. The longer leg is the shorter leg times the square root of 3, and the hypotenuse is always double whatever the shorter leg is. Okay. All right, so let's just kind of go around the classroom. Let's start with Andrea. Let's say I want to solve number 9 for x and y. Well, what type of triangle is it?
It's
45, 45 or 30, 60?
45.
45, 45. Okay. So I know this is n, and then n square root of 2. So do I know the answers to x and y immediately, or do I have to do a little bit of algebra?
A little bit out.
A little bit of algebra. In fact, what's my equation? Okay, so n square root of 2 equals 7. Or 7 equals n square root of 2. You know, the fact that we reversed them doesn't matter. So what would I do now? Divide by the square root of 2. Okay. Now those are going to cancel. And once again, we have to rationalize. So it looks like I'm getting what? There you go. 7 square roots of 2 over 2. There you go. In fact, we've only got 4 problems left. Let me go ahead and give you a little bit of time. Let's say, 3 minutes, I'll do it. 3 minutes. Get through as many of those as you can. Then we'll come back together. We'll wrap this up. And I'll go ahead and give you your assignment. Are you all done?
Yeah.
Yeah, sure. Go for it. Cool. And if you're not sure about an answer, you can confer with your villain buddy. Remember, we have these villains of the same color around you? Okay.
Oh, mine's blue. God, Joker. He's gonna laugh at me. That's not fair.
Well, the Joker laughs at everybody, to be fair. So,
But it's not gonna help me.
are you sure? Because there's no one around you who also has a blue villain?
Do you have a Joker? No, I don't need you. Oh, I.
Bless you. All right. Well, let's go ahead and get started. How about Fatima? I'm looking at number 10, and I see that it's a 45, 45, 90. Do I immediately know the values of x and y, or do I have to do a little bit of work? Uh-huh. Okay, so it is 10 as well. Very good. There you go. That's exactly right. Good. Okay. Marcus, you want to help me out with number 11? Do we know x and y? There you go, because both of those are equivalent. And what was y? 7 square roots of 2. Yes, sir. Perfect. In a 45, 45, 90, the hypotenuse is always a leg times square root of 2. Now in 12, we are going to have to do a little bit of work, right? Because what's always across from 60? Is it n square root of 3, or 2n? It's always n square root of 3. Well, let's see. I'm going to go ahead and say n square root of 3 is equal to 20. So what would I do? Divide by square root of 3. So we've been dividing a lot today by the square root of 2, but this time we're dividing by a different radical. Okay, so those cancel out. Now I want to rationalize just like we have been. Square root of 3, square root of 3. So what does it look like I'm getting? 20 square root of 3 over 3. There we go. So that's the height. There you go. So then I simply want to take that value and multiply it by 2. Now, if I have 20 square root of 3 over 3, and I want to multiply that fraction by 2, I'm probably going to do what to 2? Well, I don't need to change it. Well, I'm going to change that to a 40, but I put the 2 over 1. Because remember, you multiply fractions straight across. Okay? So you're absolutely right. 2 times 20 square root of 3 would be 40 square root of 3 over 1 times 3 gives me 3. How many people got that one right? Okay, good, good, good. If you did not raise your hand, if you didn't get right, is there anything I can do to help you out? Okay. And then this last one here, number 14, do I have to do any work or do I already know everything? Yeah, because this 20, he's across from the 30, right? So I immediately know n is 20. So what's the longer leg? 20 square root of 3. And the hypotenuse is always double the smallest leg, so that's got to be 40. That is exactly right. Perfect. Any questions? Okay. So do we feel a lot more comfortable with the 30, 60, 90 and the 45, 45, 90 now? Okay. We are definitely going to be using these when we see those inverses, and we're actually going to start those tomorrow. Well, I'll tell you what, you actually have a large amount of time left. You probably could finish your homework before you take off. We'll go ahead, have it due tomorrow, and then we'll just keep going here.